Hey, pre-calc. In this video, we're going to be talking about conic sections again, but now we're moving on to ellipses. So first, let's start with the definition and equation of an ellipse. So an ellipse is the set of all points such that the sum of the distances from P, capital P, to two fixed points the foci is a constant. Okay, so let's make a little coordinate plane. And I'm going to make this longer. Okay, and so this isn't going to be perfect, but that's okay. So let's plot a couple points and label them. Okay, so I'm going to use these to try to make a decent ellipse. Let's see how it goes. Not too bad. Not great, but not too bad. Okay, so this is going to be my ellipse. And we have our P value, which I don't know, just put anywhere on the ellipse. And then we have two fixed points, which are the foci. I'm just going to do it here and here, I suppose. So we have foci 1 and foci 2. Okay. So, alright, let's talk about standard form. We're going to keep referring to this. So for standard form of the equation, okay, there are two equations. So there is x minus h squared over a squared plus y minus k squared over b squared equals 1. Or basically the exact same thing, except we could switch these two. So x minus h squared over b squared plus y minus k squared over a squared equals 1. And for both of these, a is bigger than b. And so whichever one's the bigger one, that's going to be telling you, is it more, is it being stretched like wide like this, or is it going to be stretched vertically like this, based on which one has the bigger number. Okay, so the center is a key point. The center is going to be h comma k. And that's obviously right in the middle. Okay. H is always with the x values, k is always with the y values. And then we have the foci. So the equation for the foci is going to be h plus or minus the c value, comma k, or h comma k plus or minus the c value. This is for when the horizontal direction is your major axis, and this is for when the vertical is the major axis. Okay. The way we get c is equal to the square root of a squared minus b squared. Okay, we have vertices. So these are endpoints of your major axis. And then we have covertices. And these are endpoints of your minor axis. Oh my gosh, you can't see what I'm writing. I'm so sorry. Okay, so we have vertices, which is the endpoints of your major axis, and covertices, which are the endpoints of your minor axis. And then let's talk about major minor, and then I'll show it to you on the ellipse. So your major axis, got two in the zone there. You can think of it as your long diameter. And your minor axis, you can think of as the shorter diameter. Okay, so relating this to the diagram we have above, your major axis, like I said, is going to be that longer diameter. So the major axis for this that we drew up here is this distance. That's your major axis. Whereas your minor axis, for the example we have here, is the shorter one. So it's this one. Okay, vertices are the endpoints of your major axis. So these are your vertices, here and here. And then your co-vertices are these two, and they're the endpoints of your minor axis. Okay, and the foci, right, are going to be c away from your vertex. And this is how we find that distance. So let's do an example of graphing. Alright, so let's graph, let's find the key characteristics and graph. Alright, so if my equation is x minus 4 squared over 16 plus y plus 2 squared over 9 equals 1. Alright, so that's the equation for my ellipse. First thing that I would do is determine what's my a and b value, right? Because a and b are going to help us determine where like our c value and where the foci is. And then it's also going to let us know like which way is it being stretched, I suppose. So because 16 is the bigger one, that means we're going to have a wider, our major axis will be horizontal. So my a value is going to be the square root of that, because remember this is a squared, so a is going to be 4, b is going to be 3, which means c is going to be the square root of the larger one, a squared 16 minus b squared, which is 9. So our c value is the square root of 7. Okay, now let's go and find all the other important parts. So center. The center is going to be h comma k, so 4 comma negative 2. Okay, my vertices. So my vertices, remember, are the endpoints of your major axis. I guess we didn't really talk about how to find these, but now's the find time. So our vertices are based on, and our co-vertices are based on these two. So think horizontal dilation and vertical dilation if it's with x or if it's with y. So my vertices are going to be the a distance or the b distance away from the center. So if my center is at 4, negative 2, then my leftmost vertice is going to be 4 to the left, so 0, negative 2. And to the right, so 8, negative 2. Because that's the horizontal distance. My co-vertice, or vertices, is going to be this vertical distance. So it's going to be 3 up from the vertex or center and 3 below. So that's going to be 4. Oops, I already did parentheses. 4, comma 1. And then going down 4, comma negative 5. Okay, so that's from the center, down 3, center, up 3. Okay, so then we need foci, which is going to be 4 plus or minus the square root of 7, comma negative 2, because it's going to be on that major axis. My major axis is going to be y equals negative 2. Minor axis is at x equals 4. Alright, and then let's graph this. I don't have a lot of time left in my video, so I'm going to pause to make my coordinate plane. So my center is at 4, negative 2. My vertices are at 0, negative 2, and 8, negative 2. Co-vertices are at 4, 1, and 4, negative 5. Alright, so then this is my ellipse. And then my foci are going to be just over 6. Because 4 plus the square root of 7 is going to be a little over 6. So this is one of my foci, and then it's going to be a little over 1. So here's my other foci. And that's my ellipse.